And under the little heading of this, it really is story problems. And the book goes through some long, methodical sort of gizmo, gadget, rigmarole sort of stuff that I don't necessarily know why they do. I am just going to tell you this, ladies and gentlemen. Direct variation is nothing more than equal ratios. So I would just use a ratio box. That's what, if I were you, I would do. What you're going to say, really?
Really?
Let's look at an example problem. So when they use the word direct variation, just think of the word proportional, just think of the word equal fractions, think of whatever we use when we do that. Here is an example. The number of word Tom types varies directly with the amount of time he spends typing. You don't have to write all that, that takes forever. What did I just say? The amount of words Tom types varies directly with what? Was anybody listening?
The amount of time he spends.
To the amount of time he spends typing. I could stop and talk for a minute. If Tom types 100 words in 2.5 minutes, if Tom types 100 words in 2.5 minutes, how much longer, oh wait, no, sorry, how many words does he type in 15 minutes? How many words in 15 minutes? And like I said, you could go through some long discourse on how to do this, but really this is nothing more than a ratio box. Okay, and here you'd have your ratio. What am I comparing? What are the two things I'm talking about how many words he types and how many minutes. And what does it tell me? How many words does he type and how many minutes? At the beginning it says he types 100 words in 2.5 minutes. If that's the case, how many words in 15 minutes? You don't know how many in 15 minutes. And that really is the same thing. This is the actual thing. Now, it would be helpful for you to know, if they asked you what the constant of variation is. Does anybody know what they would be asking you? They would be asking you this, because I can tell you care ever so little. I mean much. If this thing were flipped, which way would it have to be flipped? This way. And I wrote those numbers right. The constant of variation would simply just be, what would I multiply this by to get that? Because that would be the same thing I would multiply this by to get that. I don't know how many of you have mathematical capabilities to figure out. 2.5 times what would give you 100? Thank you, Connor. Nicely done. How did you figure that out so quickly? Sure, why not? All right. So really, that means 15 times 40 is going to give me my answer, but we're not going to do it that way. I just wanted you to see that. Did that confuse you? Somebody say yes.
Yes.
If I don't confuse at least one person a day, I'm not happy. But in reality here, we're just going to set this up the normal way we would do. 100 over 2.5 equals what number over 15? If you were solving that, how would you do it? Anybody going to give me some suggestions? Does the decimal really throw you for a loop? Are you scared of the decimal? Does anybody get frightened of decimals? Can I reduce this? What would, I'm just asking, what would it be if you reduced it? Anybody?
40 over 1.
It is. 2.5 goes into 140 times, so you could just use 40 over 1. And then 1 times what is 15? 40. I'm sorry, 1 times 15 is 15. So 40 times 15 is 600. Which would be, again, if you couldn't do that, you could just cross multiply 2.5 times what number is 100 times. And you'd still get 600. That's my hope. How many people feel relatively uncomfortable about everything that just happened right there? Look at your books at page 473. Sure, I find that amusing. That was a hypothetical question, never a good answer. Look at lesson, whatever we're wrestling on, number 70, practice problem C. Let's see if you and I can't work this out together. Traffic was dense, much like the 7th grade class, for the evening commute. Mitchell traveled 3 miles on the highway in 15 minutes. Predict how much longer it will take Mitchell to reach his exit 5 miles away. What would we do to solve that there? Everybody together, all at once. Impressed. Nice. And what am I talking about? What's my first ratio? What am I comparing? I'm comparing what? Time to mile, what? Miles and minutes. And what is my miles and minutes? How many miles did he do in how many minutes?
3 miles and 3 miles.
3 miles in 15 minutes. But he needs to go how much farther? 5 miles. How many minutes would that take? And again, that should not be terribly difficult for you. Actually, it doesn't work out evenly, so we're actually going to have to do this one out. It doesn't, well, it does reduce. I'm sorry, it does reduce. Sorry. 3 over 15 equals how many over n? This reduces to 1/5. 1 times 5 is 5. 5 times 5 is
25.
25. Now, my kingdom for a horse, if anybody could tell me my constant of proportionality. What's my constant factor? What do I multiply 3 by to get 5? Everybody should know this. It's a pretty simple problem. 3 times what is 5? No, 2 point something 86. Aaron Murray says what?
5.
No, 3 times 5 is not 5. Flip that over, how about that? It still wouldn't be right. No, it would be 1.5.
1 and 2/3. 1 1/3.
Anyway, does somebody have a question? I'm sorry, I didn't. Imagine if you have a question. No? Actually, I feel better about